Hi there, and welcome to this crash course on Python basics for data science. By the end of this particular crash course, you will have learned the following concepts: variables, printing, comments, arithmetic operators, data types, lists, conditional if statements, for loops, and functions. The idea is that you will have grasped the Python fundamentals that are important when it comes to learning basically data science and working with Python libraries while you're solving for problems using the Python programming language. So in addition to the concepts, we have provided a notebook. You can think of this as a document that contains all the practice material for this workshop, and you'll find the notebook link at the very bottom of the description. So let's get started. Now, once you have followed the link at the bottom of the description that leads to the practice work, you will end up to this page, and this page actually is a notebook. By notebook, we would say that it's an environment that allows data scientists to share analysis. However, for purposes of this video or this crash course, you will be using this notebook to go through the practice material for the various concepts that had been mentioned before. So the first thing that you do once you open this particular notebook is to create a copy of this notebook. So you go to File and save a copy in Drive, and it's going to open another copy on a new tab at the very top. Then once you do that, you should have a copy of a notebook of this document that you can be able to make changes to, and you can be able to run the code, edit, and do whatever that you'd want with this particular notebook. So starting off, we are going to go through variables, printing, and comments using the Python programming language. So the first thing that you would need to do is to connect. On the right side of your screen, you'll see a connect button. I've already connected my notebook environment to servers, which actually will be running the Python code in this particular session. So once that is done, we can then go through the first set of concepts, which are variables, printing, and comments. So just unnest the section, and again you need to unnest the section again, and we're going to go through now each and every concept for this particular course. So the first concept when it comes to learning Python with regards to Python for data science is learning more of what are variables, and these are reserved memory locations that you use to store values. Normally, you could think of these as containers or temporary containers that can be used to store information before manipulation. So how do you create these memory containers? So assuming that we wanted to store the value 10 in a variable named a, the variable is now the container, we would first of all start by defining the variable name, which is a. Then we assign it the value 10. So what we have done here is we have assigned the value 10 to the variable a, and we can run this for that to happen, and that has happened, as you can see at the very bottom. So we have already assigned it, but we cannot be able to preview it. We'll be able to see the value stored in a while we're going through the printing concept. The next example, we will assign the value Earth to the variable planet, and the variable name, just as before, would go first, planet. Then we will assign it the value Earth. So when it comes to variables, you could assign values as shown here. By a value, it could be just a numerical value, and you do not need to put double quotes or single quotations. But if you're storing something that we will come to know what are referred to as strings, strings are types of data which are usually in character form, or a sequence of characters. Then you would need to have the quotations that wrap the value that you would want to have as a string. So this particular value is stored in Planet. We can run it by pressing this button, or shortcut would be Shift then return, or Shift Enter if you're using Windows. The second concept, it's printing, and the print function prints the specified message on the screen, or the specified variable. If we wanted to print and see what's inside our variables, we would use the print function. So this function is used to review what is stored in a variable. So just to go a few examples, we might also want to say so if you wanted to use our own value that we would want to print, so we could still use the print function and pass a value hello within this particular function, and this is going to print out our value on console. So we are printing it out somewhere, and in a notebook environment like the one that we are using, we are printing it out on a console, and this is our outcome. The same case here, the next example, if we wanted to print out the text hello Valentine and define a white space as a separator, we could do that by, just to explain what it means by defining a white space. A white space as a separator is the space that's in between the two strings. So in our case here, we would want to combine two strings that we have and put a separator in between. So we can use the print function, then define our first string, comma, then the second string, then we define the separator as a space. So if we run this, we should get hello, then the separator, then Valentine. We could also do something else as dash. This would be hello dash Valentine. All right, the third concept that we're going to learn are comments, and comments are basically simple notes used in our code to provide explanatory information. And we normally use comments to explain complex code that we have written. So in our case over here, if we wanted to comment this particular piece of code, we might, this is not complex, but ideally you would want to use comments when you write complex code. So in our case here, we might want to comment, provide a comment through the use of a hash character. So hash character would be that, and whatever that comes after the hash character would be a comment. So we might say the following variable stores the value 56. So this is a comment, and it won't be executed by Python once we run it. And Python already knows that because it checks for whatever text or data that comes after the hash character. And you could also use multiple hash characters to write comments. There's also another way of writing comments, but that is usually through the use of delimiters, which are simply three single quotes. So whatever that you wrap in three single quotes would also be referred as a comment. All right. So the next concept that we're going to learn is arithmetic operators, and these are mathematical functions that take two values and perform a calculation on them. So in our case, it would be addition, multiplication, of course, subtraction, division, And there are also other types of operators that might come in handy while you're working with the Python programming language, such as the increment operator, the modulus operator, and etc. So going through some of them, first of all, we would want to say create two variables, variables A and variable B, and assign variable A, assign 40 to the value 40 to variable A and the value 10 to variable B. To perform an addition operation, we would use the additional operator, which is plus A plus B. But now we are going to print out our results, so we could always assign the value, the outcome of A plus B to the variable C, so that we print it out here. So if we run this, we should get 50 as our outcome. All right. So the next thing, we could also use the division operator below. So if we are to use A divided by B, so we'll go back and see our values of A and B. So A is 40 and B is 10. So 40 divided by 10, it would be 4. If we were to print this out, we should get 4.0. The reason why we would get 4.0 would be is because any sort of operation that if you divide, say in our case here, an integer divide by an integer, you would get what is referred to as a float. But we'll come to learn more about what integers are and also what floats are. The third example, for arithmetic operators, you might want to use an increment operator. So an increment operator allows us to shorten this particular operation. So in our case here, if we wanted to write this particular operation using the increment operator, we can write this particular operation by simply saying is A plus equals to B. So this particular operation or expression is similar to this particular expression. So if you were to write A plus equal to B, I can also put a space there, we should be able to get 40 plus 50, 40 plus 10 is that's 50. So our value of A would be 50, our new value of A. So if you run this particular cell again, you should still be you should still be able to get 50. If you wanted to do a decrement operator, you would need to have a minus sign. So this is what would be referred to as a decrement operator. Data types. So data types are usually a classification of data that allows us to specify which type of value a variable contains. So a data type is basically just a classification, and this is what I had mentioned before: an integer or float and also a string. So data usually is stored in different types or in different forms. You could store it as a number, you could store it as a decimal place number, you could store it as basically a text. But when it comes to programming languages, you would refer to those different forms as data types. So there's the integer data type, which if a value is of an integer, if a value has an integer data type, then it would be either positive or a negative whole number. A string value is usually a sequence of characters, and they're usually contained in double or single quotes. Float value is a real number with a floating point representation, and that usually has decimal point numbers. So just to go through a few examples, So let's start with the integer data type. So 50 here, if we assign 50 to the variable x, we can print the type of x using the type function, and this will give us integer. We could also print the same with regards to the string data type. So print type, then x. This will give us a string data type, even if what's within the two quotes is more of a number, we would still have a string. Same case here with regards to a float. If we printed this out, we would also get a float. So we should get an integer, a string, and a float. So Python usually prints with class, but you can see int, string, float. All right. The reason why you would need to learn about data types is because sometimes data can be stored in, say, string data type. Like numerical data can be stored in string form or with a string data type. And once you say retrieve records from a data source, you might find that, yes, that data is stored in a string data type, and you cannot be able to perform arithmetic operations on that numerical data, majorly because arithmetic operations are not performed on data that's of a string in nature. So you need to convert now that data from string format into integer format or float data type in order to further perform your analysis. All right, so adding a value of integer data type with a value of string data type. So in our case here, just to elaborate more, so assuming that we had x and y, this is of integer, this is data type, and this is of string data type. If we wanted to add these two together, we would need to convert y into an integer, as you can see here, and this would in turn allow us to perform this operation here. So 40 plus 4 would be 44. So we could also perform other operations. We could also automatically have our values converted into float. Now integer values converted into float once we use the increment operator. So in our case here, say we assigned 20 to x and printed its type, you would see here that we would have integer. If we printed this, the first line we'll get is integer, class integer. Then the second one, we will get float. This, as I had mentioned, so just write a comment. So you can write a comment either the start or after the line, or in between the line, but whatever comes after would be a comment. So this would be x equals to x plus 5.0. So this, it will be 20 plus 5.0, which is be 25.0, and that would of course be a float if we were to print that out. So we should get integer, then a 25.0, then float. All right, so dividing integers results to floats. I had also explained this a bit earlier. If you divide an integer by an integer, you should get a float. So 40 divided by 5, we should get 8.0 or 8.0. So the same case, 5 divided by 40, you should get, I think, 0.125 should be that. So both of them should be floats. Right. The fourth concept that we're going to learn are lists. And lists are a compound data type that allows us to store items of different data types, but those items could be related. So in our case, we were using variables to just store one piece of data, but lists would allow us to store more data. And how we would be able to go about that. So let's go through a few examples on how to work with lists. Assuming that you are to create a list that contains information about fish names, then we would use square brackets at the very end. And each item or element in the list would need to be separated by commas. So here we have 4 items which are separated by commas, as you can see. So if we were to print out our result, we should be able to see that we have salmon, starfish, tilapia, and swordfish, but it would be in a list form. So you could also print out without using the print keyword, but you could also use the print function, but you could also use the print function nonetheless. Could also print the same, it will also print the same thing. So if, just before I continue, lists are usually important, especially when we would also, as mentioned, want to hold a set of related information within, say, one particular memory location. And it's quite common to use something like a list to store your column names and then perform a certain operation on those column names. So having a knowledge of lists usually helps a lot as a data scientist. So the next thing that we're going to do is, say, assuming that we wanted to add an element, to add another element within this list, then we can use the append method, and you would give the name, this method, the name of the item or the element that you would want to add. So you'd of course have to reference the list that you are working with. So if you run this, should be able to get goldfish at the very end. If you run this again, you will get another goldfish at the very end because it's appending to the new list that we have. Now we have our fish list has 2 goldfish. Now, if we wanted to update an element in a list, we would be able to so we would be able to first of all use what I refer to as positions within a list. So how we would do that is we would first of all look at our list. Our list here, normally a list usually has, well, to further explain this even better, I would say if the elements in a list usually have positions. So the first element usually has position 0, then the second position 1, third position 2. So lists, the positions usually start at 0. So in our case, here we have 0, position 0, 1, 2, 3, 4, 5. So if we wanted to replace the second, well, this is actually the third element because the number 2 represents the third element, and how you look at it is saying that this is the first element, so it's position 0, position 1, position 2. So this is the third element. So here you would find the position. Of course, you'd reference the list. Then you use square brackets and have the position, which refers now to the tilapia here. And we would want to replace tilapia with Nile tilapia. And once we do that, we can print out our list and we will see that our update has been made. So salmon, starfish, Nile, and tilapia. If we wanted to remove an element from a list, goldfish, so here goldfish, we wanted to remove it, we would need to use the um, remove method and pass the element that we would want to remove. So in this case we will remove goldfish, but it will remove both this particular goldfish that it was found first. But we could again remove goldfish again. If we run this again, we will also remove now the second goldfish. So we have removed that one. So the next one, the next bit about lists that we would want to learn would be to say if you wanted to reference the positions or to of a particular element in a list, just like the way we did here, we can further continue doing that by still using what is referred to as slicing when you slice a particular list. So here we would want to slice the first element in the list through the use of 0, fish, the name of the list, then square brackets, then the position, then just close the bracket and you print out the first element. But we might want also to say get the first two elements in the list by using by defining the starting position that we would want to slice the list from and the end position. So 0, 1, but the end position won't count as part of what you want to print. So the two elements, 0, the elements found at position 0 and the one found at position 1 would be what would be printed out. So as you can see, that is what we have. All right, so we are done with the lists. Now moving on to conditional if statements. Conditional if statements are usually used when we would want to make a certain decision. We usually would want, say, to execute a certain part of the code if a certain condition is satisfied. You could think of if you had a data set that had variables or had columns. One of the columns was age, and you wanted to retrieve the records with an age greater than, let's say, 40, then you can use conditional if statements so it to retrieve those records. So you would say from this data set retrieve records if age is greater than 40. Right, so conditional if statements are quite important when it comes to data science, but let's first of all see how we can be able to formulate a few just basic conditional if statements. So first, we will declare two variables, p and q, and assign them these values. Then we use the if keyword as shown below. So if, then q, this is the expression that we would want, q is less than p, and we would use a semicolon, then print out this particular statement. So if an if statement usually has a body, and a body is whatever that comes after this particular white space in the next line after the if expression, or after the expression that we have created. So in our case, you can see that q is less than p, so which means this statement will evaluate to true and this particular statement would be printed out. If this was 600, then this statement would not be printed out. But if we run this, we should have q is less than p. If we have 600 as mentioned, nothing will be printed. We might also want to have multiple if statements. So this is just one statement. So in our case here, we might want to have, let's say, if s is less than r. These are new variables that we have declared. If s is less than r, so s is less than r, which our case here it's equal, so it's not, then it would mean that this, whatever that comes in the body of the if statement, this is the body of the if statement, which contains another if, will not be executed. And what will be executed will now be the next elif or else if statement. In Python, it's usually elif. And r is equal to s. So r 100 is equal to s. This statement would turn to be true, and then this particular statement or body would be printed out. So in our case here, we would expect this to be printed out. You could also see that there's also another concept here of just being able to nest if statements, which is also a possibility. So running this, we should have r and s are equal. How can we use the else keyword? So now what we have seen here, the first one we just had, for the first example, we just had one if statement. For this particular one, we had also an elif keyword, or that would allow us to have two conditional statements. And in our third example, we could also have another condition where we would say if the second statement also does not evaluate to true, then whatever else would be executed. So if, just to explain it a bit further, so if this particular statement turns out to be false, then this particular statement would be evaluated. If this particular statement, if this expression turns out to be false, then this will be executed nonetheless. No check or anything will be considered here. So in our case here, we would want to use, say, in our case here, we would want to say, I think that's it. I think that's it. So in our case here, we would actually have this print a is greater than b as the final outcome, because a is not equal to b, and b is actually not greater than a. Now, for loops. So for loops are usually control flow statements that allow us to repetitively execute a piece of code. Assuming that you still had a data set that had 100 records, and you only wanted to perform a certain operation on maybe a certain set of records, but you'd of course need to check whether those records maybe have an age greater than 40, like the example that I had given you. Then you can use just a for loop to iterate all through those records. This is where for loops are important. That's a good example where for loops are important. So going through the first example of a for loop. So we had this. So let's consider this particular new list, which has restaurant elements, and here we would want to loop through, or to go through each and every list, and then we would want to check if the element that is being looped, the current element that has not really a looped, we would want to check whether the current element is equal to a certain value. Then if it's equal to a certain value, we would want to stop the loop. So in our case, so we would want to use the for loop through the use of the for keyword. Then x is just the name of variable, but it would be now the current element that would be the current element where the loop will be in. So in our case, if we were to loop through the list for the first time, CJs would be stored in X. If we do that for this, if we loop again for the second time, Java would be stored in X, and we can do whatever that we would want to X in terms of whatever operation. But in our case here, we are checking whether X has a particular value. Double sign we normally use for expressions equal to. We could also use three equal signs for exactly equal to. So here we would want to check whether we would want to print out all the elements that are actually up until Viridian. So we'd want to print out CJs, Java, Nyamamama, Italian, and Viridian. So we loop through the restaurants list, then print out each and every element. So each element, so loop through restaurants, print out CJs, then check whether X is equals to CJs is equals to Viridian. It's not equal, so you just continue to the next loop until we reach to Viridian. So you can see CJs, Java, Nyamamama, Italian, and Viridian. We don't print Cosa. We can use a continue statement to actually stop the current iteration of the loop and continue to the next iteration of our code. So here we used break to break out of the iteration completely. We do not want to continue with our iteration. But here we can use a continue statement to stop the current iteration and continue to the next one. So just to give you an example, here we are looping through the mobile list. So X, we loop through iPhone 4, then we check whether X is equal to iPhone 4 or is equals to iPhone 8. Then if it's true, we will stop the current iteration and we will continue to the next one. So here the output of this would be that we would go through, we would print out checked iPhone 4, checked iPhone 5. We would skip when it comes to 6. Then we would go to checked iPhone 7, then skip iPhone 8, then iPhone 10 and iPhone XS. So as you can see, we have skipped iPhone 6 and also iPhone 8. All right, for the last concept that we're going to learn is functions. So usually functions are a block of, so a function is a block of organized and reusable code, and we normally use as data scientists functions to sort of bundle a set of instructions or code that you would want to repeatedly use it to use later onwards. So you could create a function maybe to clean the column names or the column names, and assuming that you were working with 5 or 6 data sets, then you would just use that function. You'd call that function to just clean those particular column names if they can all be cleaned the same way. So you wouldn't want to write the code again and again. So going through a few examples, we'll start with some inbuilt functions. So the Python print function is also a function. Behind that is a chunk of code that we usually reference. Sometimes without knowing, when you're using these functions, sometimes you might not think of them as what I have mentioned here as them being a block of reusable codes, but they actually are. So if we wanted to find, say, the maximum of the elements in the maximum element in this list, we can use the max function. It just takes in a and checks, and also we then print out that value here. So here we would have 55, and we could also do the same here for items with highest value alphabetically by passing this list to the max function. So in our case here, we would have Susan because U, okay, yeah, because of U comes after I. So yes, S and S come after G, so it would be, this would be, would have a low value alphabetically than Simon and Susan, but Susan would have the highest. So we should have 55 and Susan. All right, so functions, as you can see, we were giving them values, like whatever comes in between the quotes, not the quotes, these the brackets is what is passed, and it's usually referred to as a parameter or an argument. So we could also create our own functions. So here we used inbuilt functions. We used print and also max function. We could also create our own functions. Say in our case, we wanted to create a function that gives us the highest, a value that has. So if we wanted to create a function to find out which of two numbers is greater than the other, then we can create a function, say using the def keyword. So def, then we write the function name in the square bracket, and the not square bracket, but the brackets and double colon. Then within our body, we would have our logic that we would want to have, and this logic would check for whether our value is greater than the other. Then we can print that out, but in our case here, we just have our values that we'd want to check within the function. So in our case, which value is greater than the other, it would be the first number. So if first number is greater than second number, we would return the first number. So functions usually return a particular value, and so in our case we would have max of 2. So if we call our function like we did here, we also called our function here. If we call our function, we should get 10 as the value that is greater. So yeah, so far we have been able to go through these concepts briefly. However, in order to extensively go through these particular concepts as you continue with your learning journey when it comes to data science, you could also go through the concepts by yourself on the practice notebook that we have provided. But at the same time, you could also go through a course which I have also linked, which is actually connected to this. This particular course contains some extensive material. So the concepts that you have there are basic, which would actually be sufficient for you to be able to perform basic data wrangling when it comes to handling a data set. But additionally, you might also want to have a look at dictionaries and while loops, but I have provided a course on Skillshare on still the same. It's a full course. The one on YouTube is a crash course, so you can go to Skillshare and get access to that course. And it will have more topics, dictionaries and while loops, and there are more examples with regards to the individual concepts. I had only included a few to just give you an idea of what those concepts might entail. In addition, there are challenges which you would work on. So after the examples for each and every concept, there are challenges which would help you to practice more, and there are solutions to those challenges which are also provided in that course on Skillshare. So be sure to check that out. I'll also be uploading the full course on other different platforms, just that maybe you might have signed up for those other different courses. And when it comes to learning data science, if you use these particular concepts in a project, then you tend to retain those skills for a long period of time. Hence the reason that in that course there is also a project and a project solution that would allow you to practice the concepts that you'd have learned. So if you'd want to get updates on future crash courses like these ones, like this Python Basics for Data Science, be sure to like this video and also subscribe. I'll be posting a video or two on different data courses or different data topics, which should bring you up to speed in a short period of time. And lastly, if you would want to learn in a live environment, be sure to also check out the AfterWork Data Science Fellowship Program, which will also help you to acquire the same skills. So that's it for this video, and see you in the next crash course that I'll be posting soon on YouTube.